Hello, mathematicians. Okay, so today we are going to be working on factoring trinomials of the form a squared plus bx plus c. So when you see a polynomial in this form, you can factor it using the method that we do today. Now, if you want to be ready for our assessment, then I would stop the video and try to solve these on your own, because this is a skill that you will need in order to master this target. Now, once you have done that, let's go ahead and take a look. Now, there are multiple ways to solve this. You can use the rainbow method, which is something that I know the videos have been showing you. You just have to make sure you multiply all the terms by each other. I've also shown you the area method. I know that this works for me because it helps me to organize. So I'm going to go ahead and do one just in case you need a reminder. So I made my 4 square. I have x times x, which is x squared, because I have 2 x's now. I have a 1 times an x, which is a 1x. Then I'm going to go x times 5. Well, x times 5 is still just 5x. I can't actually do anything with it. Remember, there's a little multiplication in there, just so you know. And then 1 times 5 is 5. Now, what that means is I do have an x squared. I do have a positive 1x. I do have a positive 5x. And I do have a positive 5. Now, I am going to combine my like terms to make sure that it's simplified. X squared is all by itself, so it stays x squared. I have a 1x plus a 5x, which equals 6x. And then my 5 is my constant, and it stays by itself. And that is in simplified form. Now, let's go ahead and do the second one. I've created my 4 square. I've got an m times m, which is m squared, because I now have 2 of them. I have a negative 4 times an m, so that's simplified. M times 6 is a 6m. Remember, we always put the coefficient first. And then I have a negative 4 times a positive 6, which is going to be a negative 24. So now I use my terms that I have come up with. I have m squared. Then I have a minus 4m, then I have a positive 6m, and a negative 24. Remember, my signs of the numbers become the operations that I use in writing the expression. So now I'm going to combine my like terms. I notice that I have 2 with m to the first power, so those have to be moved together. I have a negative 4 and a positive 6. These are different signs, so I'm going to subtract them. So let's go ahead and start with our highest power, m squared. Then I have a positive 2m and a negative 24. And for the third example, I'm going to do this one kind of quickly. Again, k times k is k squared. Negative 7 times k is negative 7k. K times negative 3 is negative 3k. And negative 7 times negative 3 is positive 21. Now, in order to write this, I put my highest power first, k squared. I have a negative 7k. I have a negative 3k. And I have a positive 21. So now I'm going to combine my like terms. My k to the first power are my like terms. And I'm going to rewrite. So k squared. I have a negative 7 and a negative 3. Since they are the same sign, I'm going to add them and keep the sign. So that is a negative 10k, then plus 21. So go ahead and take a look. If you need to practice this, we do have an additional video for you to use. Now, what's interesting is today's skill is actually to work backwards. So last week, we were working on simplifying polynomials. Now we're going to take these simplified polynomials and factor them back into this form. So that is our skill today. To factor a trinomial of the form x squared plus bx plus c, you must first find 2 integers that add to the b number. In other words, this is the sum. So we're going to go back to our diamond problems, and I'll show you how you can use your diamond problems to do this. The C term must be what we multiply. Okay, we multiply to find C. That is our product. So remember, when we were working on diamond problems, I have my diamond problem. The sum goes on the bottom. The product goes on the top. And my job will be to find the two terms that become the product and the sum at the same time. So let's do our little guided example. We've got x squared plus 7x plus 12. What two integers have a product of 12 and a sum of 7? Okay, so product of 12, I'm going to put that up here. And a sum of 7. I'm going to put my sum in the bottom. Now, in order to find this, remember there's a few things that I think about in my head. You're always welcome to take a look at the poster. But the first thing I do is I factor the 12. What are the numbers when multiplied equal 12? So I do always start with my first number, 1 times 12. Then I look and see if this is an even number. 2, 12 is even. So I know 2 does go into it. So 2 times 6. Then I check 3. Does 3 go into 12? Well, 1 plus 2 is 3, and 3 goes into 3. So yes, it does. 3 times 4. Now, since 3 and 4 are right next to each other, and I've gone in order, I know I have all my terms. So that is my first check. Now, remember, if we're working with negatives, we technically could do negative 1 times negative 12. And I could do negative 2 times negative 6. And I could technically do negative 3 times negative 4. So just keep that in the back of your mind that we could have negatives, because this is a positive answer, and a negative times a negative is a positive product. Now, my second step is to find out which of these two terms equals 7. Well, 1 plus 12 is 13, so that doesn't work. 2 plus 6 is 8, so that doesn't work. But 3 plus 4 is 7. So that means that my two my two terms are 3 and 4. My two integers are 3 and 4. So now I write two binomials using these integers, then distribute to check. So I am going to think about, remember, this is the form that I want. Actually, you know what? Let's put a little box here because sometimes it might be a negative. So I'm going to put a little box here. When we are putting polynomials back into factored form, we are going to follow this format. Something with either add or subtract. So remember, this is going to be an add or subtract. Something else times the quantity of something plus or minus something else. So I know that sounds really crazy right now, but let's go ahead and back and look at this. Remember, we have x squared. That means I have to have an x times an x. So that's pretty simple to start with. Since I have two x's here, I can give one x to each of my quantities. Now, I also know that I have a positive 3. So I am going to put a plus 3, and let me make a big plus with my pen here. And I also know that my other term is a 4. And again, it is positive, so I'm going to put a big plus sign here. And now I have my factored problem, my factored solution. Here we go. It looks like this. Now, if I really wanted to make sure I was doing this right, I would come back. If we've done this correctly, if I use my area method, it will go back to its original answer, x plus 3, x plus 4. X times x is x squared. 3 times x is 3x. X times 4 is 4x. And 3 times 4 is 12. If I combine my like terms, I've got x squared. 3x plus 4x is 7x. And I have a positive 12. Notice how this answer is the exact same thing that we started with. So we are doing basically an inverse. We're doing an opposite. We turned it into factored form, when we can actually take factored form and turn it back into their original answer. So let's go ahead and do a few practice problems. Now, you're welcome to do this on other paper, or you can put your little diamond problems over here just to help you. Now, when I go to factor these trinomials, what I do notice is I take a look at the signs. I notice that this is a positive and a positive. So that really does mean that I need an n, because notice that that's an n plus something times the quantity of n plus something. So I've got to figure out what are the two integers that will multiply to 20. So notice I already started that over here, but then add up to 9. So for 20, let's start with we always start with our product. What are numbers that multiply to equal 20? Well, I always start at 1 times 20. Then I ask myself, is 20 even? 20 is even because it ends in a 0. So 2 times 10. Does 3 go in? 2 plus 0 is 2, so no, 3 does not go in. Does 4 go in? Well, 4 times 5 is 20. Now, since 4 and 5 are next to each other, I know there's no more factors. So I'm going to decide now which of these 3 sets adds up to 9. 1 plus 20 is 21, so nope. 2 plus 10 is 12, so nope. 4 plus 5 is 9. So that means my two integers are 4 and 5. Now I take those and I put them into my quantities. N plus 4 times the quantity of n plus 5. And if I do my distributive property and I use my little area method, I would find out that this number does become this number. Now what I'm going to do is I'm going to do a few of the odds. I'm going to do a few of the evens. Your job will be to work on the odds today. So let's go ahead and do maybe a couple more. I've done one from set 1, so I'm going to go ahead and do one from set 2. So I'm going to move down here. Number 6. I'm going to make my diamond triangle first. And I know that my C needs to come up here and my B down here. My product is -8. Oh, that's telling me something is negative. So I got to think about that. And then it's going to add up to 2. So in order to find, and I'm going to kind of get rid of those right now. Something that I'm noticing is that when I multiply, I get a negative answer, but when I add, I get a positive answer. So let's look at what can become -8. What can become -8? Well, I know I can go 1 times -8, or I can go -8 times 1. I do know I can only have one negative. What are some other numbers? Let's see, is 8 even or odd? It's even, so 2 does go in. So 2 times a -4, or I can do, oops, I meant to do -2. -2 times a +4. Does 3 go into 8? Nope. And since 4 goes in, I already know that. I have found all of my terms. Now notice, some of them are positives, some of them are negatives. So let's see which ones of these add up to 2, a +2. 1 plus a -8 is a -7, so nope. -1, oh, I didn't do that right. I meant that to be the other way around. See, even I make mistakes. That's supposed to be a -1 times 8. So if I have a -1 and a +8, that equals a +7, so that doesn't work. 2 plus a -4 is -2, so that doesn't work. But -2 plus a 4 is a +2. That is my set. So now I have a -2 and a +4. I have found my integers, so now I just have to write them. Remember, I have something and something, and I just got to figure out what my signs are, right? I'll just do those really light so I can write over them. Okay, since I have x's, I put an x in each quantity. I have a -2, so I'm going to write -2. And this one's a +4, so I'm going to write +4. And that is my factored form of my trinomial. let's go ahead and do one more. Oops, my paper keeps sliding. Okay. Again, I'm going to look at my diamond problem. What two numbers will equal negative 45, but when added be a positive 4? So I'm going to come over here, negative 45. What are my terms that, when multiplied, my integers? Let's see, I could do a 1 times a negative 45. I could do a negative 1 times a 45. Does 2 go in? Is 45 odd or even? It's odd. So no, 2 does not go in, and neither will any even number. So 2 doesn't go in. Does 3 go in? Well, 4 plus 5 is 9, and 3 goes into 9. So yes, 3 times negative 15, or negative 3 times positive 15. Okay, does 4 go in? Nope, it's an even number. Does 5? Yes, 5 times 9, right? And I'm kind of out of space, but you can kind of listen and write. Negative 5 times a positive 9, or I could also have I'm just going to put another pencil or paper down here for me. Yeah, you might want to work on other paper if it helps. A positive 5 times a negative 9. Does 6 go in? Nope, it's even. 7. Nope, 7 doesn't go in. 8. 8 is even, so no. So I have found all my factors. Okay, so now which ones of these equal to a positive 4? That means my number has to, my larger number has to be positive. So I'm going to get rid of this one, I'm going to get rid of that one, and I'm going to get rid of that one, because those all, the larger number is the larger absolute value is negative. So I know it's not negative 1 and 45, because that's just way too big. So now I'm to negative 3 and positive 9. Oh, sorry, negative 3 and positive 15. That equals a negative, or positive 12, so that's not it. Negative 5, positive 9. Oh, that equals 4. That's the one I want. So negative 5 and positive 9. Those are my two integers. I've pulled them out. So I'm going to write my quantities. I know I'm going to put a C in each side. Then I'm going to use my integers that I found. Negative 5, positive 9. And that is done. Now just to remind you, and I'm going to do the area model just one more time to show that we did this right. I have a C minus 5, and I have a C positive 9. C times C is C squared. Negative 5 times C is negative 5C. C times 9 is 9C. And negative 5 times 9, positive 9, is a negative 45. When I put these together, I get C squared. Those become positive 4C, and that is a negative 45. I'm back to my original answer. So I've done it correctly. Okay, go ahead and try a few on your own. I'll make a second video for the backside.